Okay, this section is going to be on compression. Now, as the number increases, complexity increases. What this means is that the size and rate of compression, as those increase, the number of values inside of the pressurized unit increases. What that means is that as the number increases, the amount of the number of possible values increase. This means that if you have something that is, let's say, a 10, the possible values are 10 through 1. Okay? So this means that there are going to be a lot more interactions in something that has a value of 10 versus something that has a value of 1, which means that there's no interactions at the value of 1, whereas there's 10 possible rates at a rate of 10. And if you have a size of 10, that means that there are a values of 10 in a size of 10, whatever that measurement is, be it in nanometers or in some other unit. Alright? So, when you're looking at the interaction between two pressures that are coming in onto each other, you have to understand that as PA and PB interact with each other, if they are equal, then they spread out and there's no change in position or there's no influence in the direction that the pressure is changing. So if, let's say, PA is this size and PB is this size and PA is greater and pushes this way, that means that that PB is going to deform if all of a sudden PA no longer is equal but is greater. Okay? And as PA increases, what happens is that eventually you get to the point of where PA ignores PB. Alright? Now, the way to figure out exactly how much PA will interact with PB is you need to look at the rate difference. You need to look at the size. You need to look at the proximity. All of these things determine exactly how much interaction PA will have with PB. Okay? Now, the next thing to know is that the rate of decompression and compression is never a fraction or zero. What that means is that we are always going to go in steps. So it's always going to be 1 or greater. That means there is a 1 which is stable and the universe likes this, so it's just going to keep it that way. And then 2, that means that it's going to spread out at 2. And if it says 2.5, what that means is that something went wrong because this is 2.5 and you can't really split it until you realize that's 2 and 1. Alright? But let's say there's 2.25. This is not possible. Because of the fact that the universe likes to step down to 1, and it may seem to be stepping down like this, like 2.25, but what's actually happening is you have something that is spherical, right? That's spreading outwards. And for compression, whenever you have something that is a fraction, what's going to happen is that you're having multiple incoming numbers. Okay? So if you get a fraction, that is not possible, and you need to rethink your strategy because you're apparently not spreading out the numbers enough. As I said, as the value increases, the amount of possible numbers increases. Now, for a interaction, how you can figure out exactly when it's going to interact and how it's going to interact. Let's say you have two pressure waves, right? First, you have to look at the direction it's heading. Then you take the arrow that indicates the direction, and that is going to be your first contact point. All right? And every subsequent parallel point that that arrow is attached to is going to be your next interaction point. All right? That's the way that the universe considers things. So if this were a line and this were a line, then all these points would interact because they're all parallel or exactly on the same exact line as the direction of the arrow. Okay? This is the way the universe does things. Now, there's another thing to realize is that you have progression. With progression comes a new rule, which is law of minimums. What this means is that in order to determine the next number it's going to interact with after the initial interaction, it's going to look at what the next values are. Now, if all values in that next wave are the same, then it's going to just go in direction of the arrow. Go in the same direction, right? But what happens if the value for one of the adjacent next values in the line of progression is different, or let's say it's less than, then that means that that lesser value is going to be first. Okay? Now, if it is greater, it is going to be last, or it is going to be, if the greater number is close to the number that is interacting with the pressure wave, if the two numbers, two values of the expanding pressures are in close proximity to each other, what the greater value is going to wait for is going to do is going to lessen to a point of where that value is no longer greater and is equal, and it's going to end up interacting with that number, and depending on the direction it has to go into to get to that number, on exactly what the timing is and all of that, it may interact with the greater number, but it just all depends on how fast that it gets to a acceptable number. The universe does not like going up whatsoever. Now, if the next values are all less, what's going to happen is it's going to go in the direction of the arrow right? So if they're all less, this is the one that's all less. The previous one was just one that was less. It's going to go in the value. It's going to go first in the direction of the arrow. Right? But as it progresses, if the value is much greater than the other values as it's expanding, then what's going to happen is all the adjacent values are going to, on each third progression for this, all less, right? Where all of these are less values, each third progression is going to spread. It's going to cause it to spread. So, what does this mean in the terms of visual? What does this look like visually? What this means is, if you have all 2's and you have a 3 that's coming in, it's going to go in the value of the direction of the arrow, right? And if the next values are 2, then what's going to happen is it's going to go in the direction of arrows, and it's going to replace the 2's with 3. This is the second progression, right? For the third progression, what it's going to do is it's going to do this. 2, 3. For the third progression, right? This is migration. It migrates values based off of the quickest way to spread all of that pressure. And it never goes up. Unless it has no choice. What that means is that if, let's say for example, the incoming pressure is now less, let's say it's a value of 3 and this is a value of 5, what's going to happen is this is going to come in at a value of 3, but this is going to push back at a value of 5, and that means that the in-between value is going to be 4, right? It forces the value up. So if the universe has any other alternative to other than going up, it will choose that value. This is law of minimums. So if you don't see any way of stepping down or just continuing along the path at the same value, it's going to be forced to go up. But it's always going to choose to go down. It's always going to choose to go down as much as possible first. This is going to be the law of minimums. All right? To recap, just really quickly, value creates complexity. Right? Rate of decompression and compression is never a fraction. The interaction is always going to try to step down, and if the one value is much greater, then that means that the value that is less is going to be ignored. Okay? That's because it's going up in steps, and essentially what happens is it completely passes the lesser value. Okay, this is going to be the section on compression. I think there is one tiny little error. I'll go ahead and look at the video, but for now this is going to be the compression video.